Hi everyone, welcome to this other session where we shall be discussing the power supply systems, the DC power supply. So we will be looking at two kinds of power supplies. The first one is unregulated power supply and the other one is the regulated power supply. In unregulated power supply, like we have said on the board, it is a DC power supply whose DC terminal voltage is affected by the amount of load. Meaning that if the load keeps changing, the terminal voltage will be greatly affected. So we are not receiving a constant voltage at the output depending on the load. So meaning there will be fluctuations. If it is a machine that may be required 5 volts, it means at some given point you can be getting 3, or you'll be getting 4, or even you will be getting more. So that kind of power supply is not actually mostly used because it can easily affect the machine. We look at the regulated power supply. Like I've written on the board, in a regulated power supply, it is a DC power supply whose terminal voltage remains almost constant regardless of amount of current drawn from it. So meaning in this case, for a regulated power supply, the terminal voltage will remain steady regardless of the amount of current that the load will be drawing. So that is why this one is mostly desirable, especially in electronic, when it comes to the field of electronics. We now want to look at a block diagram of a regulated power supply because that is a very common area in the exams. So in a regulated power supply, the first thing that we draw is the transformer. We will have a transformer. That is the very first component that is used to build a power supply, and this one we will be talking about the AC mains. That is the input point. And then after that, we will now move to our next component. Our next component will be the rectifiers. Rectifiers. In rectifiers, we normally use diodes. We use diodes to do rectification. After these, we will now move to filters. We will use filters, and basically the commonly used component for filtration is known as the capacitors. You can use capacitors, or sometimes you can use inductors, but most commonly we use capacitors to filter. Then later on you can use regulators. After this we can talk about regulators. For regulation, we use something that is called a Zener diode. Regulation basically means you want to control, you want to adjust, you want to ensure that you are receiving something that is constant, that you can be able to control. So we want to analyze in details every stage. So in the exam you will be asked to come up with a block diagram of a regulated power supply, and we have said we are having like 4 stages: 1, 2, 3, 4, and finally at this particular point then we can write that is the regulated output. That is our regulated output. Now we want to look at what is the function of a transformer, because you will be asked in the exam to describe in details every stage of the block diagram. So the first part is the transformer. What is the function of the transformer? The transformer here will be used to step down, because in most cases, remember, what is coming from here is 240 volts. Most of the electronic gadgets will be using like 5 volts 10 volts, 12 volts. So you need to bring down the voltages. What you will use there is a transformer. So the transformer in most cases will be used for step down the voltage. Step down the voltage to the required value. To required value. So that is the function of the transformer. To the required value. The second area we move is the rectifier. Rectifier, we need to know what is rectification first. What is rectification? Rectification is a process of changing AC to DC. So rectification is a process of converting an AC signal to DC signal, and we employ rectification is a process of changing AC to DC using diodes. In this case, we will be using diodes, and that is why I've said the key component that is used in rectification process is diodes. So the second stage is about rectification. Remember, we are having an AC. We are talking about a DC power supply, meaning we are having an AC. We need to convert it into a DC. The first step was we need to bring the values down because we are having 240. You need to bring the voltages down to the reasonable or to the required value. So remember, the output of the transformer is still an AC. AC, but of a lower value. After you have done that, you now need to put it, or you need to pass it through a rectifier. The rectifier will push it down. The rectifier will now be able to convert this AC to DC. So once now you've changed it from AC to DC, we'll be having a DC at this point. But you need to be very careful. There is no machine that is 100% efficient, meaning even the conversion taking place here is not 100% efficient, meaning that the AC, some AC signals may end up reaching the other end without being converted to DC. I repeat this. During rectification, it is not all the AC signal that will be converted to DC, meaning we will be having some AC signals sneaking to the other side. So at the end here, we'll be having AC plus DC. So we'll be having some traces of AC components. Remember, we do not need this AC. That is why you need to pass it through something that is called a filter. A filter is like a sieve. When just you make tea at home, you need to sieve to remove the tea leaves. So what happens here, in this case, we are using a filter. The function of the filter is to separate the AC signals from the DC signals. What happens is the capacitor has the ability to pass the AC signals and block the DC signals. Remember, in separation you must be having some component passing and another one remaining. Just like tea, you have the tea passing and the tea leaves remaining. So what happens is, for a filter you use a capacitor. The capacitor will pass the AC signals, but the DC signals will be remained to continue to the other point. So if you put a capacitor at this point, meaning when an AC comes, it will be taken to the ground, but the DC will continue to the next stage. So that is the function of a filter. Filtration is the process of separating AC from the DC signals. So I've said now at this particular point, we have now removed the AC, we are remaining with the DC. The DC we are remaining with can be affected by this source. If the source increases, of course it can affect the DC level that is reaching this point. That is why we need to pass it through another stage that will not allow any filtration, that will not allow any fluctuations. So I'm saying at this point, this one will ensure constant voltage supply. How does it operate? It will operate in such a manner that if voltage is less, it will compensate. So that if we say we need 5, if by any chance voltage drops along this section, this regulator has got a mechanism of making up. If the voltage drops to 4, this regulator will be having a mechanism of increasing it to 5. If the voltage goes even up to 8, the regulator has a mechanism of bringing it down so that we strictly get 5 volts at the output. That is where we are saying the function of the regulator is to control the voltage that is supposed to go to the output point. So those are the commonly 4 stages of a regulated power supply that you may need. So I've said for the filters we said the function of the filter is to separate AC from DC a signal, so that now whatever that is reaching at the output is DC. So we have said the transformer, the function of the transformer is to drop the voltage to the required value. We have said once it comes here, it is rectified, meaning we are converting the voltage from AC to DC. Once you have converted your voltage to DC, you will now be able to pass it through a filter. The function of the filter is to separate, or actually to remove, the AC signals that have sneaked out of this rectification section. So meaning we are filtered, we go to the DC is passed through a regulator, so that now we get a constant output. You may also have another stage that is called a voltage divider. Once you get this output, you can decide to break down the voltages into different levels. For instance, if you need 2 volts, you don't need to come up with another voltage supply. You can use resistors. You can use resistors to break down that voltage to 2 volts, to 3 volts, to any other voltage that you may be desiring to have. In our next session, we will be looking at the various rectifying circuits. We will be dealing deeper. We'll be looking deeper into the various rectifiers that we have. For now, we will be stopping there until another time. So thank you.